Welcome to VW 8.3 Part 2. We're going to finish up our video on equations right here. So notice how right here we have a quadratic equation. So I'm going to do a U-substitution. I'm going to say let U equal sine theta. By doing this, I get 2u squared minus 3u plus 1 is equal to 0. Now I can factor it. So I have 2u, 1, minus minus. And there we have it. U is equal to 1/2 or 1. Plug it back in. So sine theta must be 1/2 or 1. And now just do your circle values. If you want, you can draw your circle like this. Half happens right here and here, and then 1 happens right there. So our three answers are pi over 6, 5 pi over 6, and pi over 2. And notice how I'm stopping there. That's because it says theta is between 0 and 2 pi. So that's important to know. This is only referring to one rotation. Yes, that's a U-substitution. For those who are really good at algebra, it's possible to just straight factor it. So some people just do this. 2 sine theta minus 1, sine theta minus 1. And notice how you get the exact same thing. It's just a little bit faster. You can do this too. Let's go to our next example. If you look at this, a lot of people want to multiply this out. Do not do that. It's already factored. So what we're going to do is just use our zero product property. Now you might not have heard of this, or you might even know you're using it. The zero product property says that if A times B equals 0, then A must be 0 or B must be 0. So we're just going to take this thing right here. This thing must be 0, or the other thing, cosine theta plus 1 must equal 0. So cosecant theta equals 2, which means sine theta should equal 1/2. Cosine theta is -1, and now we solve it. You can draw your circle here. Sine is 1/2 here and here. Cosine is -1 right there. So we have pi over 6, 5 pi over 6, and pi. Okay, two more examples. Solving a trig equation using identities. So first thing to note is look at this sine squared. And we have a cosine. So that's not going to work for now. We got to figure out what to do. So for cosine, there's not much we can do. We're just going to rewrite that. But sine squared, we can change that using our Pythagorean identity to 1 minus cosine squared, like that. Now keep going. Notice how I'm multiplying it out. It's similar to our very first example. We now have a nice quadratic. Let's make the whole equation equal to 0. So 2 cosine squared theta plus 3 cosine theta plus 1. You can do a U-substitution or just straight factor it. I'll just factor it since I already did a U-substitution above. And there it is. Cosine theta equals -1/2 or -1. I'll draw my circle. -1/2 happens here and here. -1 right there. So our answers are 2 pi over 3, pi, and 4 pi over 3. Now go to our last example. Now this one, you want to make sure you fight your intuition, because your intuition is going to tell you to divide both sides by sine. Do not do that. If you do that, you're going to miss some answers. So for this one, you always want to make it equal to 0. So you want to write this. Notice how I just subtract the sine theta. Once you do that, we have to factor. Okay, so factor. So let's take out the sine theta. That's cosine theta minus 1 equals 0. And now we have our answers. Sine theta must be 0, or cosine theta must be 1. This one's interesting because sine theta is 0 here and here, and cosine theta is 1 at that location, so the answers overlap a little bit. So the answers are 0 and pi. So the main thing to note about this problem is don't divide. And the reason for that is because, let's say we were to do that, you have cosine theta, sine theta equals sine theta. If you do this, you get cosine theta equals 1. And notice how that does match, right? But then we're missing out on this part, the sine theta equals 0 part, which we know does work. So you don't want to just divide that over like that. That's going to eliminate an answer. The exception to this rule is if you have something like this, like let's say you have sine theta equals cosine theta. In this example, you actually could divide by cosine, and that's because you're going to create this tangent right here, and then that's going to be easier to solve. So in that case, you could do it. But in an example like the one above, make sure you simply don't divide out that sine function. Okay, so finish the rest of the problems, and I'll see you in class.